Hello viewers, welcome to this exciting video. In this video, we will be looking at the November 2021 Science Paper 1, question B5. Question B5A reads, list the components of the electromagnetic spectrum in order of increasing frequency. List the components of the electromagnetic spectrum in order of increasing frequency. The examiner even further goes on to actually say that from the least to the highest frequency. So we are starting with the one that has got the smallest frequency and ending with one that has the highest frequency. So to help us better understand this question, we need to look at the electromagnetic spectrum and look at which quantity increases and which quantity decreases. So on the far ends of the electromagnetic spectrum, we have on one side, we have radio waves. Okay, we have radio waves. On the other hand, we've got gamma rays. Okay, so we've got radio and gamma. Now, what we need to understand is either ways, whether we go in this direction, there is a quantity increasing, and when we go in this direction, there is another quantity increasing. Okay, so gamma rays are the most energetic. They are the most energetic of all the electromagnetic waves. However, radio waves are the least energetic. Now, the energy of an electromagnetic spectrum, of an electromagnetic wave, is dependent on the frequency. The higher the frequency, the higher the energy. The lower the frequency, the lower the energy. Now, since we've said that gamma are the most energetic, so it means that when we go in this direction, what is actually increasing is the frequency. Okay? So the frequency is increasing in this manner. If frequency is increasing, okay, it means that the wavelength is reducing. And if the wavelength is increasing, which in this particular case, this side, when we go from gamma to radio waves, the wavelength increases. Okay? So our job here is not concentrated on the wavelength. So this wavelength, the increase in wavelength from gamma to radio waves, is none of our concern in this particular question. Our concern will be in the frequency. So in this question, we concentrate on the increasing frequency. Now, we start mentioning them in starting from radio waves and ending with the gamma rays. So let's start. Okay, so we're starting with radio waves and ending with the gamma rays. So we'll start radio waves, comma. After radio waves, what comes are microwaves. After microwaves, we have infrared. After infrared, we've got visible light. After visible light, we've got ultraviolet. After ultraviolet, we've got X-rays. Then finally, we've got gamma rays. So that is the order that the examiner wants you to list them, from the least being radio waves to the highest being gamma rays. All right, we proceed. Okay. B, mention one similarity among the components of the spectrum. Mention one similarity among the components. All electromagnetic waves we know are transverse waves. Okay, so one of the similarities is that they are all transverse waves. So we can say they are all transverse waves. But is that the only similarity? No. Yes, they are transverse waves. Electromagnetic waves all travel at the same speed in vacuum, in a vacuum. Now, for this particular point, specify the medium. Because if you just say they all travel at the same speed and leave it hanging like that, then it is wrong. Why is it wrong? Electromagnetic waves travel at different speeds in different mediums. So, because of the differences in speeds as they move from one medium to another, they all undergo refraction, which is the bending. Okay, they all undergo refraction, which is also a similarity. They all undergo refraction, they all undergo diffraction, they all undergo uh what other, yeah, so reflection. They all undergo reflection because they are waves. Okay, so all those properties of waves they will also undergo because they are all waves. So we can pick on n. They are transverse waves. They travel at the speed of 3 times 10 to the power 8 meters per second in vacuum. They undergo reflection, they undergo refraction, they undergo diffraction, and so on and so forth. Just choose one. So I'll pick on it. They travel at 3 times 10 to the power 8 meters per second in vacuum. For this one, once you leave out vacuum, your answer is wrong. Okay, so take note. So it's better you go with the easier one. They undergo reflection, they undergo refraction, they undergo diffraction, they undergo all those. Yeah, so let's proceed to B or to C. C. Mention one difference among the components of the spectrum. Mention one difference among the components of the spectrum. Okay. Mention one difference. What difference did we see? Just starting from the very beginning here, in order of increasing. Increasing what? Frequency, meaning that they have different frequencies. Yeah, they have different frequencies. They have different wavelengths. Those are differences. So the frequency of radio waves is different from frequencies of microwaves. The wavelength of radio waves is different from the wavelength of microwaves, and so on. The other thing is that they have different energies. They have different energies. We said that gamma rays are the most energetic and radio waves are the least energetic, meaning that if energy is dependent on the frequency, the same, different frequencies, different energies. So they have different frequencies or different wavelengths. So they have different wavelengths. Finish. They have different frequencies. Then, D. Give one harmful effect of the spectrum. Give one harmful effect of the spectrum. One harmful effect. So when it comes to the harmfulness of these, we actually find that depending on which part of the spectrum the harm may come, others may not pose, and what they are actually what we expose them to. I'll give an example. Long exposure of tissue to X-rays and gamma rays may lead to mutation. Okay, may lead to mutation, which may lead to cancer. Okay, so gamma rays and X-rays may cause mutation, or we may say prolonged exposure may cause skin cancer. Okay, because they're coming from outside. So those are the harmful effects of these components of the spectrum. So one, I'll be specific on this one. I'll be specific because if I am too general, one may argue that, but that does not apply. Let's take, for example, just visible light. We get exposed to visible light, but none of that happens. Okay, so I'll be specific. So, prolonged exposure can cause cancer. Yeah. All right. Otherwise, thank you very much for watching. If you are new to the channel, please don't forget to subscribe and hit the notification bell so that you are notified every time we post a video. Thank you very much.